coding with AI, man. Yeah. I am going to milk this. I'm gonna milk this AI man thing. I'm gonna turn it like a full on superhero too. I hope you guys know that. It's gonna be like superhero. There's gonna be merch. I'm gonna have like my own cape, and like my own outfit, like AI in the middle rather than Superman. I'm AI man, doing the whole thing, man. Okay, backprop for RNNs. Let's get into coding. Okay, so where did we leave off? So we have our right. Okay, so we've implemented feed forward. We have our different time states starting at t. I'm gonna call this t0. Actually, I was looking at the footage and I'm like, why the heck did I go from -1 to 1? I don't know. I'm gonna call it t. Oh, I think I know why I called it t-1 because it happens before the time starts. You know what? Whatever. Too much effort to change that. Okay, so now what I need to do is backprop. So I've already got the weight, the deltas up and running. Now let's continue going on, building out the backprop. So I have the delta for the weights. I also need delta for. I need delta for. Oh man. The Surface keyboard is actually very, very annoying. Delta for the bias. So I have bias 1, bias 2. I still don't know what to do about bias for the hidden layer. So we're just going to build this out. If it works, great. If not, we will take a look at it again another time. Okay, bias is only 1. What's the size of bias? This one's 3, and this one's 4. Okay, now we need a delta for. We have our weights, we have our biases. Now we also need delta for the hidden as well. So then this one will be so it's just going to be the hidden layer delta. So what we're going to do is we will be grabbing the is it even called a delta? I don't know exactly what it's called. I didn't even name it. Yeah, because there's delta, but then there's I'm just going to implement it. Worry about names later. Okay, actually, you know what? What I'm going to do is I'm actually going to pull these down because in our backprop, I need to be able to access. Because so this is what they initialize as, and so as we go backwards in our recurrent neural network, we just want to be able to update those weights as we go. So okay, so we have our output. Okay, so now what we're going to do is now this is my output delta. This is delta for my output. And so this one will be a quick and easy way to get the derivative for softmax is to just take whatever is the correct whatever is the correct classification and then subtract one from it, because then what that will do is that it will give it a negative gradient, which is what we want, and then everything else will have a positive gradient, meaning that they increase the error function, which is exactly kind of the behavior that we want, right? So actually what I'm going to do is, because we're in Excel, this is going to work nicely. If I do, oh, it's not. Move that down a little bit. Is equal to some product of, no, actually, I'm sorry, not some product. Is equal to this minus this. That should work pretty well. Yep, there we go. I really don't like the keyboard on my Oh, it's slowing me down. It's so weird. This keyboard on my Surface. I used to like it, but I don't know. I'm just not. Maybe I've been away from it for so long. I just find it weird. Like the function key. I need to have. It's really dumb how they did it. First of all, there's no control on the right side, so the only control is on the left side. So if I want to like just quickly move through cells using Control Up, I have to use both hands to do it, which is, I don't know, just something I'm not really used to. Let me pull out my phone and show you guys. So I need to have the function. Oh, this. I'll take a photo. So the function. Oh, why is this? So this needs to be on in order for me to be able to use key, like the F2 to go into a cell. But in order for me to use, you know, things like page down and page up to move through sheets, I need to turn this off. So it's just very, very, very annoying. Not something I'm used to. Not something I'm particularly happy with. But I don't know. Maybe I'll just get used to it. I don't know. Anyways, let's get back to this. I really should be coding in the morning because when I code at night, I'm just too chatty. Okay, so we have our delta for our output. We now need to, what I'll also do is, in light of that, I will move these guys across. Okay, so now this is, okay, so then I'll just be multiplying our output delta by the, is it the raw output? Yeah, it's the raw output. So I've gone back, we go back to our whiteboard. Our whiteboard is still active. So calculating the output delta, where's my pen? Yeah, for the very first, I guess, official Code with AI Man episode, this is very, very messy, but we'll improve and we'll move on. So this is the output delta that we've calculated. So our output delta that we have here, that's essentially, this is essentially what we've done. So we've gone back and we have, is that what we've done? Hold on. Yeah, that is what we've done. Yep, so that is what we've done there. Now my question is, oh, okay, yeah. So then this step here from going from output activated to output raw, we're then just going to have to multiply this delta. So we're just going to keep multiplying backwards in chain rule. We're just going to multiply this delta by the output raw. And so the output raw is this guy. Oh, can't use the output raw is this guy. And so that's what we're doing. So that makes sense. multiplied by our raw output. Problem arises. I think this has to be transposed, right? Yes, it does. Yeah, whatever, do your thing. I don't think that's correct. Let me think about this. Oh, right, right, right. Okay, okay. That looks good to me. So what we're doing is because we want to update, we want to figure out what the effect of the weights are on the output. So we want it to cast to a what is this, 4x3 matrix rather than just the singular cell that I had before. That's what was confusing me. Okay, so that's that, and then what we're going to do is we're also going to have to take care of the bias as well. Just see how I did it here. Oops. So same thing. Yeah, so it's pretty much just the same thing, right? So we got our output error. I really need to figure out a way to split this. Split. It's not really what I wanted. Oh, there we go. That's what I wanted. And we have, so over here I'm going to keep the vanilla deep neural network that I created, and then over here I'm going to have my RNN, just so I can kind of reference my material, reference what I've done before, and just make sure that I fully understand what's going on. Okay, so when we're doing backprop normally, what we do is we have the output. We then grab, so there's just the output. Yeah, that's just the output. We then, so this would be the squared error, or the derivative of the squared error. So 2 by that. So that's essentially what we've done here as well. So we had our output, we had our target, and then what we did was, yeah, so we had our target, we had our output, and then what we did was, actually, it's the exact same thing. We just subtracted it here too. Huh, interesting. Oh, but I didn't subtract normal subtract. I subtracted according to the rules of mean squared error. Okay. So it's target minus output, and then here I just have to multiply by 2 for that. So here what I've done is, because they're essentially this kind of the similar, they're very, very similar. So I just want to make sure, I just want to double check my work with what I've already implemented, what I know already works. So in this case, though, it's a little bit of the opposite, just because it's a different error function. So that's fine with me. So essentially, we've done the same thing. We've done the same thing here. We found our output error, and then we multiply it by our output derivative. This is normal multiplication, so element-wise multiplication. One thing I do need to keep in mind is the way my Excel sheet is built out is a little different from reference. So I'm just referencing Karpathy's code in Python. I'll just post a link in the description below. So I'm just referencing that, but the way I have my stuff built out is a little different from how he's built it out. So I just have to keep that in mind as well. And I think the orders for my stuff is just going to be a little reversed. Which is why I'm referencing my code, or sorry, my sheets as much as possible, because I just want to make sure I'm doing everything in the right order. Otherwise, this thing will never train, and I'll sit there trying to figure out what the hell's going on. So this is the output error, and then we're multiplying it by the derivative of, not output derivative, but so this is the output error for the activated. So this is the output error for, what's the word I'm looking for? This is the output error for, so after we do our calculation and we pass it through the activation function, this is the derivative of that. And so what we're doing essentially, this step here is what this refers to, and then this is just getting the derivative of here, and then you just multiply the two. You just multiply the two together according to laws of the chain rule. So it's very similar, or what I want here is something very, very similar. You know what, I'm just gonna copy Karpathy's code for now, and we'll see if that works. If it doesn't work, then I'll just see what I did, and then try to reference or try to make changes according to what I've done here. I'm just thinking a little bit. Yeah, I still believe that I need to split the order. Does it really matter? Let me see if it really matters that much, anyways. Transpose. Oops. Oh, you're kidding me. I can't do Shift F9. And whoever designed the keyboard for the Surface, it's a useless design. Okay, so it seems as if they kind of evaluated to the same thing. What I'll do is, just for my own kind of curiosity, what I will do is I will, did I delete that? What I will do is I will just keep copies of it, just in case. Just in case something goes wrong somewhere down the line, I just need to reference. I just need help with troubleshooting. Doesn't hurt to have it. But yeah, okay, so reverse that a little bit. So what I will do is I will then grab this. Okay, so that's that done. And that essentially gets us to the part where we get the output derivative and then we multiply it by our output. Yeah, so when we get our output error and then we multiply by our output derivative, that gets us our output delta. So this would be the delta for, but anyways, there's more just for me. And then for the bias, we're just adding delta y. Huh. Interesting. I wonder why that's the case. But again, I'm not really here to find mathematical proofs. I'm more here just to build it out in Excel, from my understanding, kind of see the underlying mechanics of it, and then port it to code. That's all I'm here for. So maybe next time I go through this, maybe next time what would be worthwhile is for me to use the same. Because right now this is kind of just like a raw first time going through it. But I do want to package this into more of a useful episode that people will find value from. And there's also like taking you through kind of my thoughts and how I decisions that I'm making and struggles and things that I'm overcoming and issues that I'm having and you may have as well that you may want to solve. But if I do want to package this to more like a tutorial type um, episode later in the future, what I might want to do is I might want to use the same variable names that he's used as well. But yeah, it's fine. Okay, so now we're going to start backpropping into hidden. Okay, so we've dealt with this, we've dealt with this, and we've dealt with the underlying bias that's underneath it. Bias is quite different. I haven't looked into how bias for accounting or backpropping to bias for RNNs work, but what I do know is that, or what I do remember painful reminder I have from implementing from implementing bias update in normal neural networks is that it is quite finicky, quite annoying. So I'm really tired. I'm not at the top of my game today, but I'll push through. It's 9:30. Okay, maybe I'll spend like another half an hour, and because I'm doing these as two separate episodes, what I'll do I'll just edit them as such. One I'll do a little bit of work. The other one, this is just gonna come out raw. Okay, so we need hidden output derivative, derivative. And what I'm going to do here is this one is going to be a mult of our output derivative. Where are we at? And right, okay, so now what we're doing is now we are transitioning from this layer to the next layer, and so we have to multiply by the weights in order to achieve that transition. Does that make sense to me? Right, because again, so here there are no weights, it's just the activation function. Here there are no weights, it's just the sorry, here there's no weight, it's just the loss function. Here there's no weight, it's just the activation function. Now what we're doing is moving to another layer, and so in order to move to that other layer, we have to multiply the output derivative by the weights. So that's what we're doing here. by the weights that get us to here. So these weights would be weights number 3, which is this guy. Something's not right. Okay, so in order to, okay, so I guess I have to multiply, I have to change the order of that. Well, if I have to change the order of that, then I may also have to change the order of this guy. I don't know. Again, if I get any errors, or if any, let me make this full screen. If I get any errors, I will change that up. But yeah, in order to multiply them a compatible way, I do need to just switch things up a little bit. And there we are. Okay, now this is just being ridiculous. Oh, okay. So I need to multiply this 4 columns into, so I need to transpose this. My bad. There we go. Okay, that's what I want. And that will give us a 1 by 3, which is what we're looking for, because in this layer, we're working with a 1 by 3, or we're working with a 1 by 3 vector. So that looks correct to me. That's our hidden output derivative. Plus our delta, plus I'm going to add that. Just so I account for, oh my god, this F2 thing is going to piss me the hell off. Just so I account for anything that may have come in the past for. Okay, so now that we're here, what we have to do is we now have to jump back here. And so what connects these two is just the sigmoid activation function that we've had there. So we just have to backprop through the sigmoid activation function and just get the derivative of that. So I'm just going to call this our hidden raw derivative. Hidden raw. And so in order for us to do that, we just, what's the formula for? No, he's doing tan. I need to get sigmoid. Okay, so times 1 minus it. Okay. And then what he's just doing is he's then multiplying it by our hidden output derivative. Okay, and then now we're gonna now we're gonna update our bias 1. Am I making it equal to this raw output derivative? Okay. Okay. Hold the hell up. Made a mistake already. What we're doing first is we are updating these weights, not these ones. So I'm just going to copy that, paste it there. I'm doing is I'm grabbing that, I'm adding it to, okay, so that really has not changed much. Okay, so then now what we're going to do, now we're going to update weights, the first set of weights. We're going to do that by taking our, the reason why we're doing that is, so now we are here, and so how do we get to the final part, which is just getting the derivative all the way back to the input? Well, that's just multiplying it by the weights. So similarly, when we were here, when we want to move from the output layer to the hidden layer, we multiply by the weights. Now we're going from the hidden layer to the input layer, so we multiply by the weights again. So we will take our derivative. So I need to multiply our inputs by hold up. We have 4 inputs though. Oh, okay. No, this should be fine. So you have 4 inputs. Nah, how the hell is that gonna work? What have I messed up? No, it's not gonna work though. Okay, so let's go back here. So this guy is just multiplication of what if I reversed it? So what if I did exactly how he's done it here? This would be transpose of these guys by dy. That's what I thought. Okay, I'm a little lost, to be very honest with you. Okay, wait, let me just go back, make sure everything is correct. Okay. That all looks fine to me. We have a bias. Bias 1 is only 3. Right, because there's only 1, 2, 3 there. Here is 1, 2, 3, 4. Okay, that makes sense to me. Here we have our hidden. And this is just 2 hour 1, 2, 3. Okay, that makes sense. Alright. Then we have our dy. So our output delta. So we find our that makes sense. Wait, how am I multiplying this by? What is this? Oh, that's not what I'm looking for. Clearly I am like really, really tired right now. Okay, what I'm looking for is I want you to be multiplied by, so 4 rows there. Hold on, that's even worse. Yeah, it's even worse. Okay, hold up. So that means that I need to multiply the output by here. So it's output and then transpose of there. Transpose of that. In order for them to be compatible. It should be compatible. Yeah, this is a 1 by 4. And then this is a oh, okay. Nope, sorry. So I need to multiply the transpose of this by that. So the transpose of this is a 3 by 1 matrix, and this one 1 by 4 matrix. Sorry, that's what I was going for. So that's why I said I have to reverse the order of okay. Everything's making much more sense. Okay, we're making headway. And boom, boom. Okay, now this makes much more sense to me. So then what we do is then we take this, and then we add this to our oh, beautiful. Okay, that makes so much more sense. Hold up. Nope. What have I done? That should go here. Okay. So yeah, now I can get rid of that. I don't need that. I knew something was wrong. I don't know. It's really weird. When you're coding, you have a feeling something is wrong, and you just ignore it and you move on. It just comes to bite you in the butt later on. Exactly what happened there. Or at least that's what I've experienced as a beginner. I don't know. Other people have other different, better experiences, but that's just mine. Okay. And so once again, if we don't have that there, it's still a normal 3 by 3 matrix. So then when we add it there, it then becomes a 4 by 4 matrix. Okay. Now bias is equal to our old bias plus delta output. Works well for me. Our hidden delta hidden output derivative. This is equal to dy, so delta for y, matrix multiplication. So I'm just going back. I'm just fixing a couple of wrong matrices that I multiplied by each other. I should probably just to provide value. I should probably pause for a little bit. Oh, I have to go soon. I should probably pause for a little bit and explain what it is I have done. But let me do that at the very end. So just bear with me. I just want to implement this as quickly as I possibly can because we're almost done. And once I implement this, I'll quickly do a recap. And I'll be here for today. And tomorrow we try to train it. If it works, great. If it doesn't work, I quit and I become, I don't know, a busboy. Not that there's anything wrong with being a busboy, but change profession. Okay, so our output derivative right here. So the output derivative will be here. So we'll still be working with our 1/4 matrix. So in our 1/4 matrix, what I also want to do is I want to multiply by the weights that we have. So the weights, the 3/4 matrix. So it's going to be the weights multiplied by the transpose of this guy. Right? The only way to have a that's the only way to have a compatible. The only way to have a compatible multiplication. Why did I do things so differently? Why did I think that was a good idea? Oh, like that's kind of, oh, okay. It's kind of because, kind of had to. Okay. So, okay. Just adapting as I go. Okay, so what I'm doing again for output derivative is we're just going, we're now moving from this layer, output layer to here. So I didn't want to multiply by the weights. I want to multiply by our delta output by our weights. Again, done this, but I messed up the matrices that I was multiplying it by. So because we want to multiply the output derivative, which is a 1/4 vector, by the weights that connect hidden layer to the output, which is a 3/4 matrix. So what I'll need to do is I'll need to grab this, multiply by the transpose of this. So 3/4 multiplied by 4/1 vector if I transpose this. So that's what I'm going to do. The actual weights, where the weights at? Multiplied by transpose of. See, this is why I do in Excel. I'm learning a lot and I'm understanding a ton. It may not be the most coherent. For that, I apologize. I'll try to slow down and do a better job at explaining, but I'm learning a ton. Into the delta. Okay, I like that. I like what I'm seeing. Yeah, there was no other way for me to multiply them. That's it. It's the only thing I can do. Okay, so I guess I'm just gonna leave that as is. Then hidden raw derivative. This one is going to be the sigmoid. So now we're back here again. So now in order for us to get from this node to that node, we just have to get the derivative of the activation function, which in this case is sigmoid. So we're getting the derivative of sigmoid, and then I'm multiplying that by okay, multiplying that by our hidden output derivative that we had before. And so now, ooh, Okay, I'm going to skip the bias for a second. I'm just going to go ahead. I'm going to implement the next item on my list, which in this case is so we're going to come back here, which is what messed us up before. So when we're here, what we want to do is we want to, because we're now moving from this node to the input, we then want to get we want to multiply by the weights that connect these two separate, or these two distinct layers. So this is, well, I still don't know what the size of this matrix should be, but what I know for a fact is our input is a 4x1 matrix. And so oh wait, hold up. So if our input is a 4x1 matrix, all I have to do is just get the transpose of this, right? Just multiply by 3x1. Is that literally it? Is that what I struggled with? Oh man, I'm hilarious. I am hilarious. Transpose of that multiplied by. This is why you don't code when you're tired, man. Like nothing good happens. And okay, there we are. My matrices are having a little bit of an issue when it comes to their sizing. Okay, so now let's get back to here, because we still have to incorporate this into it. But what I'm thinking is, so the reason why I know this has to be a vector, a one-dimensional vector, is because our bias for our bias for layer 1, we have to add the hidden raw derivative to our bias. And so our bias is a one-dimensional vector, and so this I know has to be a one-dimensional vector. It's just how the hell do I get it to be a one-dimensional vector? Hidden output derivative. I think the simple solution here is just take this and just transpose it. I think that's honestly the simple solution, because there's nothing else I can do. So this hidden output derivative is a function, or it's the multiplication of our weights. So our hidden to our output weights, that's a 3x4 matrix. There's nothing I can really do about that. And it's also, so it's that matrix multiplied by our delta y. And our output is a 4x1. So yeah, there's absolutely nothing I can do. We're always going to be stuck with a 3x1 matrix. So what I'll have to do is I will then just have to transpose this, and then make sure, because we're dealing with a hidden layer, make sure I add the delta from the previous hidden layer. which is all zeros for now. That gives us that. And so then when we come back to here, what I can then do is I can just multiply by the hidden derivative, which is what we needed. And oh my God, we're finally done. Okay. And so now now I have to deal with this. So this is a function of our hidden raw derivative, which is a 3 by 1 because 3, that's the output that we get from the hidden layer. So it's 3 by 1. And what we do is we multiply that by the output. Hold up, what have I done? Oh, sorry, by the input, I'm very tired. It's going to be very, very input. It's going to be a terrible, terrible video. Multiply that by the input. So yeah, we're always going to be stuck with a 3 by 4 matrix. There's absolutely nothing we can do there because it's the only way that we can get these two matrices to be compatible and to be multiplied by each other. So what I will do is I will then transpose this, and then I'll add our old weights, and capiche kaboom, that's done. And so then this will be fairly similar. I'm just going to go ahead and copy the code. Actually, what I'll do is I will add this part later. I just want to see if it works first. So this will be fairly similar, except that because now we're dealing with the hidden layer, so it's kind of the same thing. The hidden layer, we want to backprop into the hidden layer. So for this one, we're going to take our hidden or our output raw, and then we're going to multiply it by the whatchamacallit. Yeah, by the output of the previous hidden state. So the output of the previous hidden state will be this guy. And I just want to confirm. Oh, no. It would be the previous activation. Right. Okay. So I guess this is just the one part that's been confusing me. So this is literally just how you do it when we are getting the derivative for the hidden layer. All we're really doing is we're just taking our hidden raw derivative, and we're just multiplying it by the output for the previous hidden layer. Sorry, yeah, the output for the previous hidden layer. So that would be this before it then gets multiplied by the weights and it gets added to our network. Okay, so this here is a 3 by 3 matrix. Yeah, I guess my main worry is because this is a square matrix. I don't know if this is the correct orientation or whether or not I did not have to. Oh well. Okay, and the last thing is we're just gonna update the delta hidden for when we go ahead and we go to the next state. So this one will just be, we're just gonna completely overwrite it. So this will just be matrix multiplication of depth. Matrix multiplication of the hidden layer. So the weights of the hidden layer, the weights of the hidden layer is a 3 by 3, and DH raw. So DH raw is a 3 by 1. Let's just do one final pass. Okay, look, I need like a five. I'm really fried. How the hell am I? Okay, let's think out loud. Let's talk out loud. Bang it out for another 5-10 minutes, and then I'm going to bed. It's the wrong place even. What the hell am I doing even here? Okay, delta of weights that go from hidden to y, hidden to output, is equal to multiplication of the output first, so this guy, and dy. Okay, so that's why I had to do that, because they're not compatible. Whatever, man. This is my first live coding, so it's going to be terrible. I'm fine with that. You have to start somewhere, right? I knew there was something wrong. Yeah, I knew there was something wrong. As soon as I started transposing transpose, I knew there was something wrong. Okay. So if I do a matrix multiplication of my output, so my output is a 1 by 4. So for our hidden output derivative, so that means that we're going back in time. We're multiplying by the weight. We're multiplying the output derivative by the weights of that connect the hidden with the output. So we go back to the hidden layer. So what I need to do is, because again, the way I structured my Excel is quite different from the way Karpathy's code is structured. So in order for me to do this, I need to take my delta output, which is a 1 by 4 matrix, and I need to multiply it by my weight, which is a 3 by 4 matrix. So 1 by 4 by 3 by 4. Is that not what I did? Doesn't look like it. I don't know what the hell I did. Jumped through some really, really weird hoops. Okay, so then I need to transpose this guy, and I get exactly what I want without hopping through any hoops or anything like that. Now what I'll do is, now I will add this to, hold up, what am I adding? What the hell am I doing? Oh, okay, no, I know what I'm adding now. Okay, cleaned up. Now I'm adding whatever was in the delta hidden. Okay, makes much more sense to me now. I have to really edit this video. Okay, now this one, for this one, the order does not really matter because this is normal multiplication, it's not matrix multiplication. So I'm not really going to spend too much time on here. That multiplied by that, okay. Looks to be working as well as I would hope. And then pH draw. Okay, that's fixed up. That's working as well as I hoped. Okay, now we're moving through. Now our weights that connect the hidden, sorry, yeah, the input to the hidden. Now this multiplication here, again, I don't know why I have to have two transposes, but let's take a look at it. So it's multiplying. So again, once we're going from input, so once we're going from backwards from hidden to input, that's what I'm trying to work out here. So we'll multiply it by the actual inputs. So my inputs are 1 by 4. My input is a 1 by 4. Okay, so I just transpose the input. If my input's a 1 by 4 and this is a 1 by 3, it sounds like a very simple. What the hell was I thinking halfway through this thing? pH raw. Yeah, I was just highly uncomfortable with the whole transpose thing. Just wanted to make sure I have the correct shape for everything. Otherwise, it's going to be a pain in the butt once I'm going through and when there are issues or when there are errors or bugs popping up when I'm training. It's going to be such a pain in the butt. Okay. Now delta hidden hidden. Now we're dealing with the hidden. Now we're dealing with this node right here. So what we're going to be doing is, because this the activated what's it called? Is it like the activated value? Sure, I'm just going to call it the activated value. The activated value from the hidden layer is what gets fed into the current layer. So that's what we're just going to have the backprop into. And so that will be matrix multiplication of our raw derivative. So this one is a 1/3. So we're going to multiply it by the previous layer's output, which is a 1/3. So 1/3, so this one's going to have to be transposed. So after the sigmoid, because that's what gets fed into okay, but that's not what I want. Right, okay, so instead of transposing that, because I want it to be a 3/3 matrix, what I'll do is I'll transpose this instead. And that gives me the matrix I'm looking for. Okay, now clearly we can see that it was a good thing I did this, because now I fixed up, it's a different order, and I'm much more comfortable with this than I was comfortable than with the old. Okay, much more comfortable now. What I'm doing is I'm taking our activated input, or the activation from the previous layer. Forgot to grab it from the previous layer. Okay, so the activation from the previous layer, then and our hidden raw derivative. Okay. I'll probably just do like a quick explanation. Let me try a quick explanation. I'll also do a quick explanation tomorrow morning. This is going to come out very, very messy, trust me. It's like 10:30. I'm running like 4 or 5 hours of sleep. It's not good. I made the same mistake I'm trying to avoid. No, I messed up again. Of course I did. So I had it right the first time. Yeah. Looks to be the case to me. Plus that. Okay, so what this is it's our output from activated output from the previous layer, and multiplying it by raw derivative. Oh, okay. Holy shoot. Okay, so then this is then our DH raw. So that's a 1/3. hidden raw derivative, and then I'm multiplying that by the transpose of our weights. And so, unfortunately, because this is a square matrix, it's going to be a little tough for me to figure out how to do this. But let me think a little bit. Okay, so I'm just going to keep that as is, transposed, and I will see what happens, because I don't think it's being transposed for compatibility. I think it's being transposed just for mathematical reasons, which, yeah, and so it produces two very different numbers. We'll see. Okay, so let's have a quick explanation. Hopefully this doesn't come out as mumble jumbo. And that's it for tonight. Let's start from the very end here. So let's assume that we are here. Let me erase this. We also, actually, you know what? Let me just do this instead. Can I move stuff? Can I like select stuff? Whoa, okay. I want select all of them guys. Oh my god. Okay. Nope. Didn't select everything I needed. Ho 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 ho. This is nice. Okay, so recurrent neural network backpropagation. Here's how this works. So we have our, so again, let me just quickly go through the naming convention that I have here. Which is green. It's hard to see because my screen is on, it's like really, really red right now because I have flux on like extreme. So this is our, actually let me start from the very beginning. So this is the input that we have, and then these are the weights that, or the synapse, so I'm just going to call them weights. I'm going to use a convention that's used in the paper. So this is the weights h to x, because it goes from the input to the hidden. This is our hidden layer raw output. So the current hidden layer, the current time step hidden layer raw output is the hidden layer, this is the activated hidden layers raw output. These two come at the same time though. So I don't know, I can't remember why I separated them out, but I might remember that soon. So I'm gonna just put like a dotted line around these guys. This is the, so that's what these are. This down here is the previous time steps. raw output, and then there's the previous time steps activated output. This is the, so then what we do is we then add these two together, and then we get the output layer's raw output, and then we pass that through a sigmoid, or we pass that through, in this case, because we're doing a classification, we pass that through our softmax. Actually, I forgot to. Okay, come on, 5 minutes. Let's power through. Let's power through. Let's do that again. So input is connected to our the current time steps hidden raw output via WXH. So wait for layer X to hidden layer, and then we go from the raw output to the activated output here by using, we're going to be using sigmoid. So I'm going to put sigmoid here. So that's what we're going to be using. And so then for the previous time step, we have the same raw output and then same sigmoid activation as well. That goes through and that converts it to an activated output. Now, what we then do is we then take that plus the output from the current layer, we add them together, and then we pass those two through another sigmoid. Actually, sorry, we don't do this sigmoid just yet. So here, actually, I'm just going to call this. Yeah, I don't know why I drew it like this. It's very confusing. You know what? I'll do the explanation tomorrow. So sorry, but I clearly am not in the right mindset to be able to go through and process all this heavy math stuff right now. So that will be it for today. I will shoot. I'll get some sleep. Shoot. Have to kind of redraw this. Shoot my explanation for backprop with Excel tomorrow, and I'll link that to this video as well. And yeah, that's that. So thanks for sticking with me for the past hour. My sincere apologies for not explaining backprop, but I will make sure to link it in the description below, and you guys can go ahead. You guys can click that. So that, my friends, is that. That's the very first episode of Coding with AI, man. That's what I'm gonna call it.